Okay guys, we're going to continue learning with ratios and rates. What we're going to do is take that information and we're going to just kind of expand upon it and use it to start graphing these ratios and rates. So we're going to start with this example, and it says students in Mr. Webster's science class are doing an experiment that requires 250 milliliters of distilled water for every 5 milliliters of ammonia. So there's your ratio, because you saw 250 milliliters of distilled water for every, those words for every 5 milliliters of ammonia. That's your ratio language. The table shows the amount of distilled water needed for various amounts of ammonia. Just to talk about this table for a second, when we get to the graphing part of this, the values that are in the top row, those are going to be your X values. And the values that are in the bottom row, those are going to end up being your Y values when we start graphing. Okay, so I want you to kind of just keep that in mind. Okay. So part A says, use the numbers in the first column of the table to write a ratio of distilled water to ammonia. So they want us to use, remember, columns go up and down. So they want us to use those numbers. And remember, your ratio has to match your words. So it says to write a ratio of distilled water to ammonia. Well, water is on the bottom of the table, right? And ammonia is on the top. So my ratio here has to be written as 100 over 2. Okay, because my numbers have to match the words. Now the next question asks, how much distilled water is used for 1 milliliter of ammonia? So what we're doing here now is we're finding the unit rate, right? So what I'm going to do is I'm going to take that 100 over 2, and I need to find one of it. So again, I'm going to divide by 2 over 2. 100 divided by 2 is 50. 2 divided by 2 is 1. That's a 50. So my answer here is going to be 50 milliliters. So I'm not leaving, I got to keep my label, right? Don't leave that label off. So it's 50 milliliters. So then they want us to use our answer to write another ratio of distilled water to ammonia. So those are my words. So that is going to be 50 over 1. 50 to 1. Okay? So the ratios in A and B are equivalent ratios. Are they equivalent or not equivalent? Well, I just gave it away, right? They are equivalent ratios. Okay? They're the 100 over 2 is equal to 50 over 1. So when we've been through this, when you divide by 2 over 2, that's the same as dividing by 1. So these ratios are equivalent to each other. And how can you use your answer to B to find the amount of distilled water to add to the given amount of ammonia? Well, before we keep going with this, what I'd like to do is we need to let's fill in this table. Let's go back and fill in this table. So, okay, so what I'm going to start with is our unit rate. So we have that 1 milliliter of ammonia for 50 milliliters of distilled water. Then you see that we have 3 milliliters of ammonia here. So if you ask yourself, how do I get from 1 to 3? Well, you guys know you're going to multiply by 3. So 1 times 3 is 3. That means you have to multiply 50 by 3, and we're going to get 150. So that means I'm going to fill in 150 here. Okay? So then I'm going to again take my 1 over 50. So what I'm doing is to complete this table, I'm putting that ratio into simplest form to figure out what's missing. Okay? Because that makes it easier with these ones that aren't friendly numbers with the 2 over 100 to figure out. Okay? So if I go from 1 over 50 to 3.5 over something, you know to get from 1 to 3.5, you're going to have to multiply by 3.5. 1 times 3.5 is 3.5. Then you need to multiply 50 by 3.5. And you're going to get, and of course you should be using a calculator for that, 175. So this is 175. Okay. And then, I'm going to switch colors here. I'm going to take my 1 over 50. And we see now I have the 200 for my denominator. How do I get from 50 to 200? Well, I would multiply by 4. And if I multiply my denominator by 4, I have to multiply my numerator by 4. So I'm going to get 4 over 200. So now I have my table completed. Okay. I'm going to erase this a little bit and then just circle it so it looks better. Okay. So now I'm going to go back to part D. Part D says, how can you use your answer to B to find the ammonia of distilled water to add to a given amount of ammonia? Well, I just showed you, right? We're going to multiply the amount of ammonia by 1 over 50 so we can figure out how much we have to add. So we used equivalent ratios. We used equivalent ratios to fill in the table. And that is exactly what you've been doing for the last several weeks. You've been making these equivalent ratios, okay? We could figure out what was missing since we put that 2 over 100 into simplest form. Okay, so complete the table, write the equivalent ratios as shown. So what they're doing here, it's just the same ratios from your table, but instead of it being ammonia to distilled water, now it is distilled water to ammonia. Okay, so you're still comparing the same things. You're just reversing the order that you're comparing them in. Okay, so we have 100 over 2. That's still a ratio of 50 over 1, right? Which that still matches this ratio up here of 3 and 150. And then it still matches the ratio from the table above of 3.5 to 175. And from 200 to 4. And then we have our 250 to 5. Okay? So all we were doing is using, making equivalent ratios from those tables. And again, I really want you to take away that the top of the table is going to be your X and the bottom of your table is going to be your Y. Okay? Okay, so we're going to look at this reflection. And so we're looking for a pattern here. And so we talked about when we first started ratios that these tables that we're working with, when you start working with them, we called them rule tables, right? So there was a rule with the X and there was a rule with the Y and there was a rule from X to Y. So here it's kind of like that. We're looking for a pattern. So what they're saying is when the amount of ammonia increases by 1 millimeter, the amount of distilled water increases by what? By how many millimeters? So if you look, ammonia I put in light blue for you, and distilled water I put in yellow. So you can look across the denominators and see when I go from 2 to 3, my numerators go from 100 to 150. So that's an increase of 50. And then I'm going to skip over this one of 3.5 because that's only increasing by 1/2. And then if I go from 3 to 4, my numerator goes from 150 to 200. So another increase of 50. And then if I go from 4 to 5, my numerator goes from 200 to 250. So when the ammonia increases by 1 millimeter, the distilled water increases by 50 millimeters. Okay? And that should tell you, like I'm sure your science teachers would say, that ammonia is more potent than the distilled water. So you should need more water to dilute the ammonia. So then their question is, So if there are 6 milliliters of ammonia, how many milliliters of distilled water will we need? Well, you could just say, we know we're going to need 50 more than what we had for 5, so that's going to be 300 milliliters. Or we could take that 50 over 100 or over 1 ratio, and we know that we're going to use 6 milliliters of ammonia. And how do we get from 1 to 6? We multiply by 6, and then that means I have to multiply 50 by 6, and 50 by 6 is 300. So there, we know that we're correct. So I just made an equivalent ratio to make sure to check my work. Okay, so not really much of what I've said so far today is new. So this part is a little bit new. So what I told you is we're going to take this information of creating these ratios, and we're going to start graphing them. So I told you the information going across the top row of the table are the X, and these will be your Y. So this is the same information with the ammonia and the distilled water. We already had our table filled in. So part B says, write the information in the table as ordered pairs. Use the amount of ammonia as your X coordinate and the amount of distilled water as the Y coordinates. So they filled in some of the coordinates for us. So now we're just taking the information from the table and creating ordered pairs. Okay, so that's pretty easy. You've done this before. You just didn't know that you were creating ratios when you were doing this in the past. So our first set of ordered pairs is going to be 2 and 100. Then we're going to have 3 and 150. Then we're going to have 3.5 and 175. Then we're going to have 4 and 200. And our last set is 5 and 250. So now we have our ordered pairs listed. So they want us to graph these on the coordinate grid. So they gave us a grid here on the right. I circled it for you. Because fractions and decimals can represent amount of chemicals, and then we're going to connect the points. So we're going to then describe the graph. So here's what I want you to notice. The axes going across the X here, and this is the Y, the scales are not the same, and that's okay. Your scales don't have to match, and if you were going to use graph paper, like in class, to make a graph, and a lot of times you'll have to do that. Alexa, stop. Then you would have to, make your own graph. You're not going to go out 300 places on a piece of graph paper. I'd have to give you probably 20 pieces of graph paper for you to do that. So what you need to do is represent, each block represents a certain amount. So if you look going up the y-axis here, each of these blocks are 50. And each of the blocks coming this way, they are in ones, but if you look at the information that we're going to be plotting on this graph, your x coordinates only go up to 5. So that's okay. So that'll work out. But your y coordinates, they go up to 250. That's why they made each block 50. So you have to think before you make a graph, what should my scale be? Okay? All right, so you have to remember how to plot a graph. And what you're going to have to do, remember, and I've heard kids say this, you have to go into the elevator before you go up. So that means you need to go right along the x-axis before you go up on the y. So I'm going to come over 2 on the right, on the x, and then up to 100, and I'm going to make my point there, right here. Okay, so there's my ordered pair. And I would normally label that to 100, but it's hard with this electronic pencil. It kind of gets messy. So I'm going to erase it. But I would like you to label yours in class. So there's that. Then I'm going to come over 3 to the right. That's my next ordered pair. And up to the 150 mark. Okay. Then I'm going to come over 3.5. So it's going to be halfway between the 3 and the 4. and then up to 175, which is going to be halfway between 150 and the 200. So it's going to be about there. And then I have 4, so I'm going to come over 4 on the right and up 200, which is about here, okay? And then if I connect these, I have a straight line. So my graph is a straight line. Okay? Now it says, for each ordered pair that you graphed, rate the ratio of the y-coordinate to the x-coordinate. Okay, so remember, in your table, here's your y to your x. So they want you to write that ratio. Okay, so it should be 100 over 2. Okay, then 150 over 3. So here are those ordered pairs. You're just kind of writing them backwards. 175 over 3.5. And then we would have 200 over 4 and 250 over 5. Okay? Hope that makes sense for you. Okay, so we're just going to keep going and filling in the questions that they ask for this activity. So part D says the ratio of distilled water to ammonia is what? Well, we've already filled that in previously, and you know that it's 50 to 1. How are the ratios in C related to this ratio? Well, your ratios in C were 100 over 2, and then you had that 150 over 3, and so they are all equivalent. They are equivalent. Equivalent. So if we reduced all of those ratios, we would end up with this 50 over 1. Now part E says the point 2.5, 125 is on the graph, but not in the table. The ratio of the y-coordinate to the x-coordinate is what? How is this ratio related to the ratios in C and D? Well, when you look at 125 over 2.5, let's put that in simplest form. Okay, I'm going to move it over so I have a little bit more room to work, and I'm going to change my color. So if I go 125 over 2.5, and I put this into simplest form, that means I'm going to have to divide by 2.5. So I'm going to, in my calculator, I'm going to take 125 divided by 2.5. I get 50. So I end up with 50 over 1. So how is that relation? How are those ratios related? They're also equivalent. And you guys know I might spell that wrong. Whoopsies if I do. So they're also equivalent. And that ratio, again, is 125 over 2.5. Okay? And then it says 2.5 millimeters of ammonia requires how many millimeters of distilled water? Well, 125, because we just had that ratio. And then it says, what do you think is true for every point on the graph? Well, what do you think that graph, so we're talking about ammonia and distilled water, right? So if I go back to the graph and we look at it, so you see if I had 2 milliliters of ammonia, I had to have 100 milliliters of distilled water. If I had 3 milliliters of ammonia, I had to have 150 milliliters of distilled water, right? So what do you think is true for every point? Well, every point shows the correct amount of water and that is your Y. For ammonia, that is your X. Okay, we're going to take a look at this one. This is what you have, what your assignment is like, informative. And so I gave you this informative in 3 questions. So like this is one question to fill in the table. This is another question to write the equivalent ratios. And then the third question is to graph it. Okay, so that's all I gave as the assignment. So it says here, the ratio of oxygen atoms to sulfur atoms in sulfur dioxide is always the same. The table shows the number of atoms and different quantities of sulfur dioxide. Complete the table. Well, what you see here is you have your sulfur atoms and your oxygen atoms. And the sulfur atoms are going to end up being the X. The oxygen atoms are going to end up being the Y. So if I look at the first column here, I see 6 over 12, or 6 to 12. What I'm going to want to do is put this into simplest form. So I have 6 over 12, right? And I'm going to divide that by 6 over 6 to get 1/2. Then what I can do is fill in this table a lot easier, because then I can say if I have 1/2 and I need to get to 9, how do I get from 1 to 9? I'm going to multiply by 9. Then I have to multiply 2 by 9. 9 times 2 is 18. So this is going to be 18. Then if I have 1/2 and I need to get to 21, how do I get to 21? I need to multiply by 21. 2 times 21 is 42. This is going to be 42. Okay. And then if I have 1/2 and I need to get to 54, how can I get from 2 to 54? Well, I'm going to multiply by 27. Then I have to multiply my 1 by 27. And this is going to be 27 over 54. Okay. So I made equivalent ratios down here to fill in my table by reducing that first ratio to simplest form. Okay, so I'm going to get rid of this. Okay, so then this part of the question where it says, what are the equivalent ratios shown in the table? All that you need to do here is just write them. So you're going to say, so we can say 12 over 6 is 1, 18 over 9, 42 over 21, and 54 over 27. Okay? And then the last part here is they want us to use the table from exercise 1 to graph the relationship between the sulfur items. I put this graph into the answer, the show your work question in the formative, so that this is already in there for you. You just need to use the scribble tool to plot the points. If by chance you accidentally delete the graph I put in for you, you'll just have to draw your own and do your best with that, okay? So we're going to try that out and see if it works, okay? So just use the scribble tool to plot your points there. So we already have our X and Y labeled on the table. So you know you have to come right first along, because this is my X, this is my Y. I have to come over 6 on the X, up 12 on the Y. There's that one. And you should label it. It is tough with the electronic pencil to do that. I'm going to come over 18 on the X. Oh, I'm sorry. Whoopsies. I messed that up. I'm going to come over 9. And if you look at this scale across the bottom, it's into 3s. And this scale is in 6s. So it's going to be this mark between the 6 and the 12. That's 9. And I'm going to come up 21. So that's going to be halfway between this mark and the 24. So it's going to be right about there. Okay. Ooh, not 21, 18. What are you doing, Eccles? Come over 9. Come up 18. It's right there. Sorry about that, guys. Okay. I was looking at that number. Now I'm going to come over 21 on the X, halfway between 18 and 24, and I'm going to go up 42. And right there. Okay. And then I'm going to come over 27. It's going to be right here on my X. I'm going to go up to 54. And that's going to be right there. My old eyes have trouble with these little graphs. Okay, so there I plotted those points. You'll see when I connect those, I have a straight line. Okay, so that's it. That's our lesson for today for the guided practice. This was 7.1. Okay, thanks guys.